Chapter 5, very first thing we've got here is they're backing up the exponents. And with exponents, here's the thing that they're looking at when they're backing up for the parts on this one, is they're going to have you go back and just do your basics on your exponents. So very first thing is they're going to do is they go way back to the beginning and just have you work with problems that you're going to do something like -2 to the third power. And where we are, we're in section 5.1. It's just exponents. And again, next time I'll have it laid out so you can see exactly each objective as we go through that, so we can make it all match up. And if you're going through, and again, I'll get y'all the list of this one. This would basically be objective 1 that's on the list in chapter 5, and we'll just kind of roll through all these so you can see what's going on. So first thing is it's just -2 to the third. So again, that's just -2 times -2 times -2. Multiply all that together, answer is going to be -8. Second one they do basically along the same lines as if you do a negative squared, and it goes back to the old basic exponents, basic properties of math. If you've got -6 squared, you're going to do -6 times -6. Okay, if you do a negative times negative, it's a positive. Do 6 times 6, that would make it 36. If we were doing this one back here, if you multiply the first two numbers together, -2 times -2 would be a +4. And then you're going to multiply that by -2, and then that's where we're getting the -8 from. So, very first thing they're going back to on the exponents in 5.1 is just multiplying out the different parts, and they're just going to ask you to evaluate or to simplify. And you're just going to multiply out the numbers to get what you need to do. After they get you some with just whole numbers, or in this case, integers, the second example that they go back and do, the second objective that they have, is where they start giving you some fractions. Where you've got 3/4 to the third power. Okay, so that one's the same thing. It's 3 to the 4th times 3 to the 4th. Or sorry, 3/4 times 3/4 times 3/4. And as far as multiplying fractions, just multiply straight across the top. So on the top part, you've got 3 times 3 for 9. 9 times 3 for 27. On the bottom part, 4 times 4 is 16. 16 times 4 would be 64. Okay, and then the next one that they do is still working through the numbers, still having to do exponents, to working through the parts. They throw a negative at you. Big thing you've got to realize, especially with a negative, where the negative is makes all the difference in the world. If you've got a negative, kind of scrolling back up to the first example, if you've got a negative on the inside of the parentheses, if it's squared, you've got to use that number 2 times, so it's -6 times -6. If they give you a negative that's on the outside of the parentheses, the negative is going to stay there, and then you're just going to use it once, basically. So then it's -5/2 times 5/2 times 5/2. So, and it's almost like you could just put a 1 in front of this one. So it's -1 times, go ahead and do 5 times 5, which is 25, times 5, which would be 125. On the bottom, 2 times 2 is 4, 4 times 2 is 8. And the negative that was out front, it just stays out front, and it's just there basically one time. So a negative on the inside, use it ever how many times it tells you the exponent is. If the negative's out front, you only basically use it just one time. And probably one question that a lot of times that they'll spin off this one, that kind of goes along those same lines, is if they gave you a number like negative, and a lot of times they'll do this just to kind of show you what the difference of where that negative is, what it makes. If you had -2 squared, that's negative 2 times negative 2. Negative times negative is a positive, 2 times 2 is 4. Where if you don't put the parentheses, if you just put a negative 2 squared, if that negative is not in the parentheses, you only use it one time, so this would be the negative of 2 times 2. So the answer would just be negative 4. So that's really the biggest thing they're trying to hammer home in the first part when they talk about the exponents and where the negative is. That where the negative is how many times you're going to use it. So if it's in the parentheses, you've got to use it, whatever your exponent is, 2 times, or if it's to the third power, you're going to use it 3 times. If there is no parentheses, or if the negative is on the outside of the parentheses like this one was, you only use that negative sign one time, and then you go ahead and do the exponents and multiply out through the numbers when you go through the rest of everything. Okay, so first few questions, it's just going back to the basics of just, here's a number, here's the power, and whatever your power is, you're just going to multiply that number that many times to get what you need to do. Okay, the first kind of real rules, properties, whatever you want to call it that they throw at you, comes in with, it's about halfway through section 1. Okay, pen's not working. There we go. Let's try that again. Okay, so they're going to talk about multiplying different variables along the way. Here's the big thing you've got to get for this one. That if you have variables that you're going to multiply together, really it's 2 steps you're going to do. If you have coefficients, and again, if you don't know what coefficients are, that's the numbers that's in front of the variables. You go ahead and multiply those together. Okay, when you get to the actual variable parts, all you're going to do is you're going to add the exponents. Of the same variable. I think they're going to talk about multiplying univariate and bivariate expressions. And again, I forget the exact wording on it, and I'll get those to you next time. But basically it's that. So they're going to give you some different examples, and they're going to have you work through these and just figure out some different parts of it. And it should look something kind of like this. And this would be example 3. So you'd have negative w to the 6th power and then times 7w to the 6th. Okay. And one small thing you can do when you're going through these, anytime you've got a negative just kind of hanging out there, you can always go back and put a 1 here. So it's like negative 1 w to the 6th times 7 w to the 6th. So basically for this part of it, you can break this up into 2 parts. You can do negative 1 times 7, and then you've got w to the 6th and then w to the 6th. So it basically you're just rearranging the terms. If you've got negative 1 times w to the 6th times 7 times w to the 6th, just rearrange it so you've got the numbers in front that you're going to multiply, and then you've got the like variables that you're going to do. From there, you just multiply. Negative 1 times 7 is negative 7. Since you've got 6 w's and 6 w's, you've got 6 and 6, you add them together, and you just make it w to the 12th power. Okay. So really the big thing on that is if you're going to multiply variables together, all you're really going to do is add the exponents as long as they've got the same variable. If you've got different variables, So maybe something like this. We've got 4w to the 6th times 2x times 5x to the 9th and w to the 7th. Okay. And again, you can basically go back and rearrange them all to do what you want to do. If you just do the numbers, you've got 4 times 2 times 5. Just pulling out the numbers here so we've got them all together. You've got then the w to the 6th. That's here. You've also got a w to the 7th that's here. You've got this 1x that's by itself, and you've got this x to the 9th that's here. And then the one little extra you've got to kind of put on the side. Variables without a power. Basically just have an understood power of 1. Kind of like if you just have an x, you don't have to put a 1x in front of it, just like if you have an apple. You don't have to say, I have 1 apple, unless you just want to. Same thing with these, is that if you've got, for this one, you've got w to the 6th, you've got w to the 7th. For the x, it doesn't have a power on it. So that one, basically go back and put a 1 there. Okay, and then you can do it basically in 3 parts. That you've got 4 times 2 is 8, 8 times 5 is 40. For the w's, you got 6 here and 7 here, so you can put those two together and make it w13. The x's, do 1 plus 9, then you make it 10. Okay, and that would be the final answer that you're looking for that one. Okay, so after a couple of problems where you're doing multiplication, just having you work through those, the next thing they're going to have you do is then go on to doing some division. And everything in the division is going to be just the opposite of everything you would do for multiplication. You're going to divide the coefficients. Now, and really more in this case, if it's fractions, you're probably, well, you're going to either divide or simplify the fraction. It just depends on how the number is set up. Sometimes you actually can divide it. Sometimes, you know, if the numerator is smaller than the denominator, then you can't divide it. You just have to simplify it. So depending on how the numbers go, you're either going to divide or simplify the fraction, and then you're going to subtract the exponents. And again, still like variables. So if you've got x's, you can subtract the exponents on the x's. You know, if you have y's, you subtract the exponents on the y's. Okay, so they start you off with something like 20wx over 24wx. Okay, so it starts you off with a really easy one where in the beginning, and this one you can almost go back to like 7th grade math on some of the problems here. On these, since they're basically the same variable, technically they're both to the first power, you can subtract 1 minus 1, and again, basically you're just knocking those variables out. You've got the same thing on top and bottom with the same exponents. You know, just mark it out. Same thing with the x's, you can just take that one and mark those out so that they're gone. So really then all you've got is the 20 over the 24. And then from there you can just simplify it as much as you know how to. For those you can divide them both by 2, but you also could divide them both by 4 to get them simplified as much as you can with one step. If you do it by 2 and then do it by 2 again, that's fine. But 20 divided by 4 would be 5, and then 24 divided by 4 would be 6. Now, one little thing that you've got to kind of put in with this one, and it kind of came along here with this problem. But I guess one little side note you've got to have. If you do anything to the 0 power, because we'll start subtracting exponents, so sometimes like technically back here when we had with the W's, we did 1 minus 1 because we do the top minus the bottom, that would have been W to the 0 power. But anything to the 0 power is going to equal 1. So technically back here we've got W to the 0 power, that part would have been 1. Same thing with the x's, it would have been x to the 1 minus 1. It would have been x to the 0 power, which would also have been 1. So, when we did this, it was really 5 over 6 times 1, but when you multiply by 1, it doesn't change anything. So the numbers are just those. Has anybody ever shown y'all why that is? Kind of give me a visual. I think I was a senior in high school. First time somebody ever actually showed me that. We went to a small school. And I had basically the same math teacher from 9th grade, would have been all the way through 12th grade. And he retired my senior year, the summer before my senior year, he retired, so we got a different math teacher. And it was always one of those things where if we did something, it was just because Mr. Green said to do it that way. So we got the new math teacher, and he would ask us questions like, why'd you do that? I was like, well, Mr. Green told us to. He's like, well, why'd you do it? Well, Mr. Green told us to. He's like, no, why did you do it? And we were like, we don't know. Mr. Green just told us to do it. And so he would stop and actually explain. He's like, well, here's why you would do this. And I was like, oh, okay, well, that makes sense. And this was one of those things where we had one of those things where something with 0 power is just 1. That's just the way it was. And, that's the rule. That's just, you do it. But if you kind of back up for a minute, let's take something that we know, 5 squared. That's 5 times 5, that's 25. Okay? If we went 5 to the 3rd power, that's 5 times 5 times 5, be 125. Even if we had 5 to the 1st, you just need 1 5, it would just be 5. Okay, so if you go up a power, if you go from 5 to the 1st to 5 to the 2nd, you're going to just multiply by 5, right? Every time you go up a power, or every time you go up an exponent, you multiply by 5. What if you go backwards? What if you go from 5 to the 3rd down to 5 to the 2nd? If we go in reverse, what do we do? You don't multiply by 5, you would just divide by 5, right? Because you're taking a 5 off. So if you go in reverse, you're going to divide by 5. So 125 divided by 5 would be 25. 25 divided by 5 would be 5. So if you want to get down to 5 to the 0, 5 divided by 5 would be 1. And then, so I was always one of those people, I'm like, okay, but if it's something to the 0 power, shouldn't it be 0? That was always my thought. And so I asked the question, I'm like, well, it seems like I understand that. I'm like, but shouldn't it be 0? And they're like, well, okay, let's just say it is 0. Let's take it up to 5 to the 1st power. If you go up a power on the exponents, you just multiply by that number, right? But what's 0 times 5? That's 0. Well, if I make it 5 squared, now I'm going to take this answer and multiply it by 5. What's 0 times 5? Still 0, right? So if you start off with something that's 0 and you keep multiplying by a number, it never changes. So then exponents don't work because everything is just 0. Kind of like if you start, you can't build something from nothing. You've got to have at least some little something there. If it's a totally sterile environment, you don't have any germs, you don't get any bacteria, and nothing grows, you got to put that one little speck of bacteria in there to make it grow and go from there. So, that's why it has to equal something, so that at least you've got something to grow off of. If there's nothing there and then you multiply nothing, then it's still nothing. So finally I was like, okay, well that makes sense now. So you've got to have something so that you can make this thing grow there. Okay, now, and they kind of, maybe getting just a little bit ahead of where we're going, but we'll go ahead and put it in here because it kind of fits in with this. What if you keep on going in that direction? What if you take another power off? Keep taking a power off. Well, now we're down to the negatives, right? Well, if you do 1 divided by 5, it's 1/5. Take it down another power. Well, now we're going to take this answer and divide it by 5. All right, and if you haven't done division in a while, if you start doing fractions and division, basically what you can do is that if you remember or don't remember from 7th and 8th grade math, the shortcut is that you're going to keep it, change it, and flip it. And you may be like, well, how can you flip this number if it's just a number? If you're dividing by a whole number, technically it's over 1. So if you keep changing flip, it's 1/5 times, flip this upside down, make it 1/5. Well, now you can do 1 times 1 to make it 1. 5 times 5 would be 25. So that'd be 1/25. Okay. Now, here's the big connection, and I think it's maybe a couple sections down the road where they really dig into this, but we'll go ahead and show it to you now because it just kind of fits with what we're talking about here. The big connection is that the only difference between it's got some lag here that's throwing things off. The only difference between a positive exponent and a negative exponent, it's still 25, but this one is going to be 1/25. So if we did 5 to the third, it was 125. If you do 5 to the negative 3, okay, the lag here is terrible. Well, again, we could divide it by 5, but the only difference between the positive and negative exponents is, again, instead of being 125, that just would be 1/125. So the only difference between positive and negative exponents is if you have a negative exponent, you just take everything in the numerator and you move it down to the denominator. If you had something in the denominator, you would move it up to the numerator. It just flips the fraction upside down is all. That's the only difference between positive and negative exponents, is that if you have a negative exponent, it just takes what the normal would actually be if it was positive and just flip it upside down. And that's what they'll keep working on as we kind of keep going through the different parts of the sections. Okay, so that's kind of a little side note that if you don't know about the 0 power, that's where it all ties in from. Now, they can have you do other things because they can give you something to the 0 power and then have you add 3 or multiply by 5 or divide by 7 or something like that. But if you have just something to the 0 power, it's always going to be 1. But then you can do other stuff too after that. You can add, subtract, multiply, divide, and change it after that. But that particular one piece of it would be that way. Okay, so this would be example 6, or objective 6 when we go through these. Here's one where they're going to change it up so we've got just a little bit of something different. Maybe b to the 6th, a to the 2nd, over b to the 4th, and a to the 3rd. Okay, and I always teach this one a little bit different than the way the book does a lot of times because they just, it works well, but this was something that always worked for me. If I know I've got to subtract the exponents for the b's, I'm going to do 6 minus 4, right? 6 minus 4 is 2, so that's b squared. And here's where you always have to kind of know about with the numbers. Wherever the bigger exponent is, that's where the answer is going to go. So if you've got a 6 on top and a 4 on the bottom, that b squared is going to be on top. Okay, when you subtract 2 and 3, or you can, and I always tell people don't worry about the numbers, just subtract 3 and 2. So A, if you do 3 minus 2, well, that's 1. Where's the bigger exponent, though? It's in the bottom, right? So that means that answer of A to the 1st has to go on the bottom. And it goes back to the way back when you first start doing these. If you had B to the 6th, they would tell you you write out 6 B's. You write out 2 A's. You write out 4 B's and you write out 3 A's. And then you just go back through and you cancel out everything that's got in common. And then you go back and say, all right, well, where's all the leftovers? Well, I've got 2 B's on top and I've got 1 A that's on the bottom. So it's taking that same thing of just canceling stuff out. You know, and it's fine when it's small numbers, but when you get into the 40s and 50s, you don't write out 40 A's and 50 B's and start doing everything. So the shortcut is just subtract your exponents. And don't worry about the positives and negatives just yet. As long as everything is positive, just subtract the exponents, and wherever the bigger number is, that's where your leftovers have to go. And again, if it's a to the first, you don't have to put that. You can just put that as a. Because again, if you leave the power off, they're going to automatically assume it's to the first power. They may or may not. Some books are picky about whether you put the 1 there. Sometimes they're not. Just kind of depends on what mood the computer's in when they go through that particular question. Okay, and then the last objective that would be in section 1. Basically the same question, just a little bit different example. (20v squared w to the 5th) and then 5v w to the 3rd. Right, and again, without any powers, that's an understood 1 on the v. So for the and you can take it really a piece at a time. You've got 5 will go evenly into 20, so that's 4. So that would be on top. With the v's, you've got 2 minus 1, so it would be a v that's on top. With the w's, 5 minus 3, that's w squared. That one is also on top. If there's nothing on the bottom, because we've got a fraction bar here, if there's nothing on the bottom, it's like an understood 1, because everything would cancel out. If there's nothing on the bottom, you don't even need it, so then you can just say it's just 4v w squared. And there is nothing on the bottom for that particular one. Now, if everything cancels out of the top, you know, if it had been reversed here, well, instead of doing whatever here, let's just do a different example. Hang on. This would be like 7b or 7a. Just kind of, let's go backwards here. Let's say it was 3x to the 3rd, y to the 5th over 12 x to the 6th and y to the 10th or something like that. Okay, now if you've got, and again, if it's on the bottom, where the bigger number is on the bottom, you're not dividing it, you're just simplifying it. So for one like that, you'd have to divide both of these by 3. Well, if you divide them both by 3, that would go 1 time, and that would go 4 times. Subtract 6 and 3 on the x's. It's going to leave you with x to the 3rd. And again, the bigger exponent's on the bottom, so that's going to put the x to the 3rd on the bottom. If you subtract the y's, it's 10 and 5. So these are the 5, but again, the bigger exponent's on the bottom, so you put the y to the 5th on the bottom. And the 4 was also down here. Okay, if you didn't, just remember, if you start canceling everything out and there's nothing left in the numerator, you still have to put this 1 as a placeholder. Because denominators, it's always, if there's nothing there, it's understood 1. You know, if you had a problem like, you know, if they said make 10 a fraction, to make it a fraction, you would just put it over 1. Okay, so, you know, that's kind of a built-in part of it there. If it's something where everything's out of the numerator, you have to put a 1 in there for a placeholder. It's got to have something there. So if everything cancels out of the numerator, you still have to put a 1 in there just to hold it on to it as a placeholder, so that you've got both parts of the fraction. Again, if it's a whole number like this one was, it's always an understood fraction that you can just put a 1 on the bottom and you've got your denominator.